Node.js anti-patterns and bad practices. Why is this guy talking about this? Node.js keeps getting more and more adopted by large enterprises. The benefits of Node are getting established. So more companies are feeling more confident about adopting Node. Companies with big names have led the adoption of Node, and the rest of the enterprise is just following along. That's why at WildE, we've been seeing more and more developers coming into Node from other backgrounds. And in most enterprise settings, these are developers that are looking to be productive as quickly as possible. And as we all know, when compared to Java and .NET, Node.js has a different programming model and culture. So it's no wonder that this clash of paradigms leads to the emergence of anti-patterns. I'm Igor, and I'm principal engineer at WildE. For more than 2 years now, we've been helping our clients adopt Node.js safely and as quickly as possible. That includes helping them contain and control the risks of this paradigm clash. And a big part of our work is educating our clients. This includes advising them on best practices. And so we had plenty of exposure to mistakes enterprise developers make when rushing into Node. Besides just telling them what they should do, we also wanted a list of things that they should watch out for. So we took a deep look at our engagements history, and we tried to aggregate and distill the most common and the most problematic anti-patterns in enterprise Node.js projects. We ended up with a long list, but I've tried to select the most important ones for this quick talk. And remember, this is based on our experience, so your mileage may vary. To help with our narrative, let's try to think of a fictional character named Jane. She's going to be our hero for the story. Jane is an experienced Java developer for a big company. Her experience with JavaScript is limited to all jQuery-based web apps. And Jane's mission is to build a Node.js prototype that will hopefully become a new first-class service. So let's try to place ourselves in Jane's shoes and try to get a sense of what this journey looks like for her. We've seen that the very first type of mistakes that Jane is likely to make are related to the use of JavaScript on the server side. It's not even Node.js specific things. You have to remember, her experience is limited to all jQuery applications. And while these mistakes may seem silly to us, the reality is that we see them happening over and over again. First mistake. Jane learned that doing I/O in Node involves callbacks. But Jane wasn't used to having to chain so many callbacks. The amount of chained I/O she needed to perform in browser applications usually wasn't that big. And I really don't want to be the guy telling you about callbacks today. It's the most basic anti-pattern of all, but we can't ignore it. We all know why this is a problem. The code base gets hard to read, hard to change. We got extra references, etc. But Jane is learning this slowly. This is a real-world example. It's the type of thing we run into. This was a module, file module that fetched task from Redis. And the road we need to guide Jane into looks something like this. Jane, it's a good idea to name your functions. Jane, there's this thing called hoisting. It's pretty cool for readability. Jane, functions should really go in the most outer scope as possible. And it's easy to do now that you've done the previous steps. And oh, Jane, you should try to avoid being repetitive with error handling. And now that you understand all this, Jane, you should really use async. It makes your life easy. All right, second mistake. Coming from strong typed languages, Jane used to rely on the compiler to verify that interfaces were being used with the proper types. So the way she starts defining interfaces for constructors and functions in general is to provide an ever-growing list of arguments. It actually takes some time until she learns that it makes it harder to change the API that it makes it error-prone for the interface users, and it makes it hard to set default values. And this is because usually the API starts small, but then options grow in complexity. Developers like Jane are used to strong type languages like Java and C#, where implementing the options pattern implies defining a class just for that. And it's just too much work. And that's until they get used to JavaScript. So Jane needs to understand that when a function takes more than 2 or 3 arguments, she should consider using an object instead. Third mistake. Jane is feeling a bit more comfortable using JavaScript. She learned that functions can be invoked with a different number of arguments. She also learned about the special arguments variable, and she finds this useful because she was used to doing method overloading in Java. But if you abuse it, it becomes unnecessarily confusing. It becomes hard to handle all the different cases. So if Jane wants to be successful with JavaScript, she will sooner or later prefer just using an object, an option object instead of trying to mimic method overloading. With Java, Jane was forced to place each class in one file. In browser JavaScript, there are no rules, and optimally you want to deliver a big concatenated file. In Node, there's no compilation step, so you're not forced to do anything. So this is why we believe this is another anti-pattern. We're talking about huge file modules, poor separation of concerns, testing becoming harder than it should. The most frequent examples we find are having all the request handlers on the same file module, or modules with a big series of unrelated functions. So what Jane needs to realize is that it's much easier and much quicker to create file modules in Node than it is to create Java class files. So her gauge for when to put things in a different file needs some adjustment. She'll see that small modules with clear interfaces are easier to test, and sometimes complexity analysis tool will help here. Coming from Java and translating classes into prototypes, Jane's used to classes and creating objects using the new operator. Fortunately, she thought, JavaScript also has a similar way of creating objects from classes. But the reality is that even the use of the new keyword in JavaScript is mostly unnecessary. It's harder to introduce object caching later on if you want to. It's hard to switch to functional programming. You can't just return things anymore. And worst of all, if you forget to call a constructor without the new keyword, you'll get strange behavior with no warning. And overall, as you can see in this example, modeling by relying on too many constructed objects makes your code look like Java, which can annoy most Node developers. So we need to tell Jane about the revealing pattern. The second set of mistakes that Jane is likely to make are more specific to the way Node works. So Jane spent a lot of time developing and debugging until she finally got a feature working, and she ships it. But turns out that some of those pesky callback error arguments were being ignored, which leads to some mysterious bugs. And this is unfortunately another anti-pattern. It's too easy to forget about handling errors. And the debugging experience usually ends up with a feeling of, this is why Node sucks. So here, using a linter that makes the right checks can help. Jane is still finding the best way to glue things together, and she's coming up with small utility functions that she keeps on a utils.js file that just keeps growing. So when she needs the same function on her second module, she isn't sure whether to copy the file module around or to promote it as a very weird Node module. It's also sometimes called MISC or common. So Jane will need to learn that in Node, modules are cheap. Modules may be too big, but no module is ever too small. She should embrace the single responsibility principle, and she should use individualized repositories for Node modules, regardless of if they're public or private. Turns out this sync versus async thing is still not very clear to Jane. She copy-pasted a snippet of code from Stack Overflow and put it on a request handler. It all seems to work in her environment, but as soon as the service gets a bit of load, it becomes unresponsive. And Jane is thinking, it seems like Node doesn't scale. So what Jane needs to learn is that there's a set of operations that should only be used in the initialization phase. After the process starts handling concurrent requests, those operations should not be called. Jane learned about streams and she started using them. In one instance, Jane had three streams and she piped them all together, but she missed some details of what would happen in an error scenario. Eventually, this makes for another mysterious bug. This is something that even some relatively experienced Node developers don't know. When a stream throws an error or closes while piping, the source stream is not properly disposed, and therefore resources may leak. This happens because the source stream isn't destroyed when the target stream closes. So let's take a closer look at the problem. Say you have three streams: the source stream, the transform stream, and the write stream. If there's an error on the transform stream, the target stream gets destroyed, but the readable stream doesn't. It's left dangling. The same thing happens if there is an error emitted in the write stream. The transform stream will not get automatically destroyed. So this means that you need to carefully handle every stream pair that you're piping together. That means this pair and this pair also. So what's the right solution for Jane here? Jane needs to learn that when using stream.pipe, she either needs to listen for error and close events on every stream and do the proper cleanup, or she can use the pump module instead of the native stream.pipe. In the first option, when using stream.pipe, she needs to listen for error and close events on every stream and do the proper cleanup, something like this. Or she can use the pump module. It will take care of properly handling the close and error events by disposing of all unclosed streams. Changing how require works. The fact that in Node, the paths for file modules are relative is annoying Jane. Coming from Java, Jane was familiarized with a global namespace. She feels that using the default Node way forced her to have ugly require paths. And she claims that it makes it harder to move code around. So the default behavior just feels wrong to her. And eventually, she found a way to fix it. She found out that you can fiddle with the node path environment variable, or that there are these modules that allow her to change the way require works. All she really wants is for the require paths to be absolute, that is, relative to the module root. And you need to understand that for someone in Jane's shoes, the idea that it will become easier to reason about the structure of the module if you do this can be appealing. Yes, it becomes easier to move file modules around in and out of folders, but the big problem is it also becomes easier to create dependencies across folders, and this is where cohesion tends to get lost. So what's the lesson for Jane here? If you look into most of the best modules out there, require paths with lots of dots isn't something you find often. So the right approach is about how Jane organizes her code and models her problem. Ideally, Node modules are small, so folders aren't even needed. But when they are, every folder should encapsulate a domain and abstract it away in a concise way. Each folder should be what's described by Eric Evan as a bounded context. So no file module inside a folder should ever require another file module inside the sibling folder. Another painfully recurring pattern, the monolith, views and APIs that end up cohabiting the same module, services that perform unrelated functions, huge code bases. Node is great for prototyping, but that can sometimes be a trap. So Jane tends to stuff everything into the same code base. And we all know this results in poor test coverage. It gets harder to make changes. It's harder to collaborate. You get longer delivery cycles. And you spend more time onboarding and hand-holding new collaborators. So Jane's story goes something like this. It starts off by being a small service that will talk to a backend system. It starts by just holding a few resources. And now it needs some authentication. and session management. So let's bake that in. It powers a single page application, and CORS is a hassle. So let's make it also serve the static assets. Oh, and now we have something that should really be another app, but it needs to use the same authentication provider and some of the API endpoints, so it's more convenient to just put it there also. And then we need billing and support for multi-country VAT. So let's add it there also, and so it goes. And when Jane realizes what she's heading into, it's always too late. She'll realize that she should have kept views separate from the API, thought of modeling the problem with many small modules, and not been afraid of breaking down services. Now it's just harder to deal with. So Jane is now doing unit tests. Back when she did Java, she would have a unit test for each Java class. Now she's writing a test suite for each JavaScript file. And in order to achieve a relevant test coverage, Jane's team tends to expose some internal details of the module. And then every time an implementation detail changes, someone in the team wastes a lot of time updating the failing tests. So Jane needs to keep the tests at the interface level. All that the test should require is the main module. She should focus on testing what the module should do and not on testing the implementation details. She should try to keep modules small and externalize functionality as much as possible. She'll eventually learn to try as hard as possible to not conflate concerns in the same module. As new members come in to collaborate on Jane's project, Jane finds that there are issues when collaborators are setting up. Things work well in her development environment, but not on everyone else's. Here's an example of how it happens. A developer writes a test suite using her favorite testing framework. She edits package.json and adds a command that uses that testing tool, and everything runs great. Then a collaborator joins the project, runs npm test, gets a command not found error, and realizes she needs to install the tool. It's annoying, but it doesn't seem like that big of a problem. But the reality is that there's just no control over the installed version on each developer's machine. They can have different behavior. A flag might not be supported by all versions. And this gets even more complicated when you couple tools together. For instance, using a linter, code coverage check, transpiler, minifier, etc. So Jane eventually learns that when modules declare executables, they are made available under node modules/bin, and that this folder is added to the search path by npm before it runs any npm script. Jane says that the team is testing their code, but bugs are still slipping into production. And some team members are even claiming that tests aren't that useful. The problem is that Jane is just not measuring test coverage. It turns out that there's a lot of code that isn't actually being tested. And without code coverage, Jane can't be sure of what is being tested. We also find that code coverage can be a very good indicator of quality. The solution could be simpler. We just need to tell Jane about a tool like Istanbul. The best thing for Jane to do is to make it part of the acceptance process, using Git hooks, for instance. The pre-commit module is great for that. Or she can also track it using something like overalls. Sometimes we find that Jane doesn't seem to be comfortable with the idea of having a long list of dependencies. She fails to leverage the rich ecosystem of public node modules. And she's unaware of the price she's actually paying for disregarding the public registry. NPM has like 250,000 packages, and several hundred packages are created every day. So why isn't Jane making good use of NPM? It could be that they don't know about the existence of a certain module. It could also be that they are reluctant to use third-party packages in general, or that they're unsure of how to deal with a lot of dependencies. Sometimes it's just that they're not breaking the problem right. Imagine a requirement for a node module tool that goes like this. I need a testing framework that computes code coverage and sends coverage stats to coveralls.io. There's no module for that. But if they break the needs down, then it becomes easier. They need to learn to choose each tool that does one thing and does it well, choose tools that play well with others, and build just a bit of glue that exposes a simple interface congruent to your needs. Sometimes Jane's biggest issue is just that they're not sure how to select the package. How to select a dependency is more of a problem in Node than in any other ecosystem of public packages. Okay, so Jane's project is now ready for production. The team gets excited, but the cheering stops when they start getting production traffic and they start looking at the performance metrics. Processing large quantities of data was rarely a problem in Jane's previous Java days. She isn't used to be wary of these situations. But now her application is having some hiccups. A simple filter or aggregation over a large data set can delay the event loop, causing latency bubbles. There are different ways this can happen. Jane needs to know that for large quantities of data, she must either schedule small amounts of work at a time, that might mean doing streaming, or offload the workload to another process, preferably with the more appropriate runtime. And last one for today, Jane learned how to use async to manage iterations involving asynchronous I/O. But she didn't dig deep enough to be aware of the dangers of not putting a limit on concurrency. But Jane can later notice high latency at times, and possibly only observed in production, which can seem somewhat correlated to request frequency, but not entirely. For a high enough number of concurrency, the event loop gets clogged with too much CPU work. Many operations started in parallel can lead an application to have hiccups. This is the kind of problem that may circumvent the whole test suite and CI checks and only show up in production. Here you can see an adapted example of a request handler on a messaging app. This handler is used for retrieving a conversation. This service call needs to get the entire user profile for each conversation participant. What happens when the conversation reaches hundreds of participants? User profile.get operations will get started on the same event loop tick. And this clogs the event loop, making this application less responsive and also making it prone to memory exhaustion. So in this case, Jane needs to sacrifice response time for the greater good and limit the concurrency. This way, she'll ensure that this will not overwhelm the event loop. And that's it. The main takeaway here is Node is fundamentally different from other technologies used in big teams. And adopting Node means adopting newer practices. I just showed you some of them, but there are more. And I hope this talk helps you form a better idea of some of the most basic problems you have to face when adopting Node from an enterprise perspective. Thank you.